It's a right triangle.
Oh no!
That's not.
Weird.
Oh, yeah.
Today we're going to continue our talk about the unit circle and how trigonometry plays within that unit circle. So some of the things that you see today will be kind of repeats of things that you already know. So be ready for that. And I hope it's that way for you. I'd like to look at the triangle that's on the right-hand side, associate some numbers with it so we can kind of see what this means as far as numbers go. So I'm going to just assume maybe that this side would be a 3, this side is a 4, and the hypotenuse is a 5. And then I just want to put in perspective what each of these values are. So for example, if I'm looking at the sine of the angle theta, and in our course, we often use two different things to represent angle measurements. Not always, but often. Theta is probably the #1 symbol they use. It's a Greek letter, and they like it just because. So oftentimes they'll use that as the variable. We'll also use t. They like to use the letter t. And sometimes they'll use x and y, but usually it's theta for t. So theta is the angle that you're using. If you look at the sine of that angle, it's the opposite side over the hypotenuse. So in this case, the sine, if we look at the example that we wrote down, would be 3/5. The cosine is the adjacent side to the angle. So here's my theta again. Don't forget that's where it is. Everything's in reference to your angle. So my cosine would be 4/5 because it's the adjacent side over the hypotenuse. And then the tangent is the opposite side over the adjacent side, and that's going to be 3/4 or 3/4. And a lot of people struggle to remember like which one's cosine, which one's sine. So you probably learned a while back that there's a tool to help you remember. And you look at the first letter in each of the pieces. And the sound tool that they used was SOHCAHTOA. The thing that's interesting is yesterday we talked about these things called reciprocal functions, and it might not have made a lot of sense when we were talking about them. But like the cosecant is the flip of the sine. So if I know what the sine is, I can just flip that fraction upside down, and that's my cosecant. So the cosecant in this particular case would be 5/3 for this triangle. And so the way I do things and the way that works for me, which may or may not be the way that works for you, is I don't memorize all 6 trig functions and what they are. Like, I don't know that the cosecant's the hypotenuse over the opposite. But what I do know is that the sine is the opposite over the hypotenuse, and the cosecant is the flip of that. So I can find one thing and then just flip it. So that's how my brain works with it. Again, if that doesn't work for you, figure out another strategy. Secant is the reciprocal of the cosine, or in other words, flip that. So the secant in this case would be 5/4, and the cotangent is the flip of the tangent. So in this case, it would be 4/3. All right, let's do some examples. In #1, we need to draw a triangle that represents what we see. And whenever I draw right triangles, I don't really know why this is. It's just maybe the way I grew up with it. I always put my right angle on the bottom right side. And then I always put my angle on the bottom left side. And they tell us that the sine of this triangle is 7/25. So I know that that means that the right-hand side is 7, because that's the opposite side. And I know that means the hypotenuse is 25. Now, if I'm going to do all of my trig ratios, I need to figure out what that final side is. How would I do that? So if you use the information they gave you, you have a triangle set up like this, you're trying to find the final side, you would use the Pythagorean theorem, and we find out using the Pythagorean theorem that the final side would be 24. So now if I want my 6 trig ratios, what they're talking about is that you're looking for the sine, the cosine, the tangent, the cosecant, all that stuff. So I know that the sine of my angle is 7/25. I know that the cosine of my angle is 24/25. I know that the tangent of my angle is equal to 7/24. Once I find these three, I don't have to really do any more work. All I've got to do is flip those. So now I know that the cosecant, which is the reciprocal function for sine, will be equal to 25/7. I know that the secant, which is the reciprocal function for cosine, will be equal to 25/24. And I know that the cotangent, which is the reciprocal function for tangent, will be 24/7. Number 2. This time they give us a tangent. Oh my goodness, there's not a fraction. What number is actually on the bottom of the 3?
1.
A 1. So don't forget that. There's a 1 there. I'm going to draw my new triangle. Here it is. My theta's on the left. Again, you don't have to draw your triangle this way, but this is the way I draw mine. Tangent means opposite
Over adjacent.
over adjacent. So this is a 3 on the right, a 1 on the bottom. I need to use the Pythagorean theorem to find the hypotenuse. You have 60 seconds, find it. Okay, number 2. Using the Pythagorean theorem, we find out the hypotenuse is
Square root.
square root of 10. A squared plus b squared equals c squared. So 1 squared is 1 plus 3 squared is 9 equals c squared. 1 and 9 is 10. Square root is usually plus or minus, but we're talking about a side length, so we don't use a negative. Now I'm going to write down some trig ratios. So I start writing down the trig ratios, and I look for the sine of my angle. And the sine is the opposite over the hypotenuse. Should I leave it that way on a test? No. What I should write then would be 3 radical 10 over 10 after I rationalize the denominator. I'm not going to do that anymore. I'm not going to simplify any of my answers. I assume that you can do that. We've talked about this quite a bit in our course already. I'm going to leave that up to you. Right now I'm just going to write down what I would get to start with. The cosine of the angle is equal to the adjacent over the hypotenuse. Again, you'd bring that radical up to the top, take it off the bottom to simplify. And the tangent of that angle is equal to the opposite, or, oh, they gave it to us. It's 3, or 3 over 1, I guess, if you wanted to write it that way. The reason I don't want to, in the beginning when I do these, to rationalize the denominator, is it's a lot easier to flip my ratios if they're not simplified. So like if I had to go back and simplify the 3 radical 10 over 10 or to do the trig ratio for the cosecant, I'd have to have 10 over 3 root 10. And then when I rationalize that, then I have to do a lot of simplifying. But if I leave it to begin with, then I know that this is just the square root of 10 over 3. Makes my life a little bit easier. And then the next one for the secant, when I flip it, it's just radical 10 over 1, or I can just write down radical 10. And for the last one, for the cotangent, I get 1/3. So in the end, you have to have everything simplified when you write it for the final answer for the test. But when you first start, it might be in your best interest not to rationalize so that you can just get the reciprocal very quickly. Okay, just a word to the wise. Okay, one of the toughest things I think in math, at least for me when I was a kid, is like reading a problem and figuring out what to do with it. So that's called decoding. When you read something and you try to figure out what is it telling me I need to do. Whenever you see something with the given point, I want you to think triangle. Code words. Good test-taking skills are going, oh, this means do this. So when you see the given point is blank, I want you to think about drawing a triangle. Let me show you what I mean. Here is a coordinate axis. And if I look for the point -5, -6, 1, 2, 3, 4, 5. There's -5 on the x-axis. 1, 2, 3, 4, 5, 6. There's -6 on the y-axis. They're talking about the point down here. And the triangle that I'm talking about always goes from the point to the origin. So I go from the point to the origin, and from the point to the x-axis. Always. So the point to the x-axis, which means the x-axis is the other part of my triangle. So here it is. That's my triangle. And in this triangle, you can obviously see where the right angle would be if this is a right triangle, which it is for our purposes. And the theta is always next to the origin. Theta inside triangle next to the origin. So my theta is right here. So I look at my triangle. What I noticed from the point was that I had -5, so this is -5 here. And I noticed that I had -6 here. So that was my triangle. I have to use the Pythagorean theorem to find the hypotenuse. I'm just going to tell you what it is. For the sake of time, you can check it later. So 25 and 36 is 61. Take the square root. So this side is the square root of 61. Now, normally when we talk about triangles, we never label sides as negatives. And so what I want to tell you is when you're working with trigonometry, you have to keep the negatives involved. If you don't keep the negatives involved, you won't have the correct trig ratios when you get there because it determines which quadrant you're in. Like when we were talking about angles and spinning around, and what quadrant do I lie in, the negatives become very important. So you have to leave the respectiveness of where they are. So these are actually like vectors more than they are lengths of a triangle side. Okay, so vectors we'll learn later in our course if you haven't already learned about them, are a direction and a distance together. A directed distance. The reason I need this is because now when I talk about my trig ratios, if I'm talking about them, I can do things like, oh, what's the sine of my angle? And I look on my triangle and that's the opposite over the hypotenuse. So that's -6 over radical 61. And again, we would never leave the radical on the bottom, but for the sake of what we're doing right now for this problem, we're going to. The cosine of that angle is the adjacent side to theta over the hypotenuse, or in other words, -5 over radical 61. The tangent is the opposite over the adjacent. So the opposite is -6, and the adjacent is -5. -6 over -5 is positive 6/5. So you can simplify that part of it. Negative divided by negative is positive. And then if I want the cofunctions, I can do the cofunctions by just flipping. So the cosecant, which is the flip of the sine, would be equal to radical 61 over -6. Remember with fractions, you can have the negative on the top, you can have the negative on the bottom, or you can pull it out in front. I don't really care. The secant, which is the reciprocal of the cosine, will be radical 61 over 5. And just for fun, I'm going to put the negative on the top this time. Because again, it does not matter where you put the negative. When a fraction's negative, it can go on top, bottom, or it can go in front. So that means that for my cotangent, when I flip, I don't have to worry about a negative in this case. I just get 5/6. No negatives involved.